Hello class, in the previous lesson we were doing an introduction to arithmetic sequences. In today's lesson we're going to strengthen our understanding of arithmetic sequences. The learning intention of today's video is we're going to quickly review how to determine the value of any number in an arithmetic sequences recursively, and then we're going to be looking at how to determine the value of any number in an arithmetic sequence explicitly. Before we start our lesson, I just want to quickly show you the results of our exit ticket, which I asked you guys to do last week. I think only about 5 students have completed the exit ticket, but I'm very happy with the current scores and results that you've actually obtained. This shows that you've got a really high understanding of this topic, which is really great to do. For those students who haven't done this yet, I highly recommend that you do this towards the end of today's lesson if you've got time. Now, I'm just going to quickly go over all the things that we've covered last lesson very briefly. We looked at what sequences are, and we said that sequences are sets of numbers or items, in this case, that follow a particular pattern or rule. So they just list down all these numbers as well as these objects over here, and each of these lists have a certain pattern that describes how do you obtain the next item or the next term within the actual sequence itself. At the beginning of last lesson, I showed you some very interesting sequences where it might have some very interesting patterns, but the only sequence that we really need to focus on is a sequence which we refer to as the arithmetic sequence. And now this slide over here pretty much summarizes what an arithmetic sequence is. It's where the difference between one term and the successive or the consecutive term has a common difference. So therefore the rate which it goes up by or down by is the same. So for this example over here, this goes up constantly by +1. So therefore this is a characteristic feature of an arithmetic sequence. This one over here goes up by +3, and in the other one, this one goes down by the same rate, -5. And this amount is what we refer to as the common difference. Now, last lesson I also discussed that there were 2 ways that you could actually obtain or find out the value within an arithmetic sequence. We could actually do this recursively. So this is a very long, tedious method, and we could also do this explicitly. We're going to just quickly revise over what the recursive formula or the recursive method is. So if you wanted to find out the next 3 terms in the arithmetic sequence, what you have to do is pretty much find out the previous number and then keep adding it on by the common difference. So in this case over here, since we're trying to find out the next 3 terms, effectively we're trying to find out what T5, T6, and T7 since we know the first 4 terms within the sequence. Now, to find out the 5th sequence, I need to know what my the 4th term and then add it by the common difference. In this example over here, the common difference is going to be 7 because it increases by +7. So adding 24 to 7, that gives you 31. Do the same thing to find out T6 in this case, which is 38. Do the same thing to get T7, which is 45. So this is pretty straightforward. So I'm just going to quickly go through this. And then we looked at how do you actually represent an arithmetic sequence recursively. So the way that we do this recursively is we express it in this particular form over here, and all we really needed to do was just substitute what is the value of the common difference and state what is your first value in the arithmetic sequence. So let's look at the examples down below. So in this case over here, my first term is going to be 3, and the common difference in this case over here, it goes up by the same amount, so it's going to be +7. So all I do is substitute this over here and substitute D over here, and in doing so, this is going to be my answer. Do the same thing for the part B. So in this case, my first term is going to be 11. The common difference in this case, it goes down by -3. So D is equal to -3, and substitute the values in. So therefore, this is going to be the recursive formula for this particular arithmetic sequence. Remember, you only need to know 2 things in order to find out all the terms in the sequence. Just know the first term and then find out what the common difference is so that you can actually find it out. Alright guys, please pause this video right now. This is pretty much going to be your little entry ticket just to see how much you remember from the previous lesson. So there are 2 parts to this question using the exact same arithmetic sequence. Firstly, write down the recursive formula for the arithmetic sequence below. And then also write the next 3 terms in the arithmetic sequence as well. So please pause this video right now and then we'll go through the solutions. Now, if you've done this successfully, what you need to do is write down what the recursive formula is. So in this case, my first term is going to be 5. And in this case over here, it's going down by -4 this time. So it's going down by 4. So T1 is equal to 5. The common difference is -4. So all you need to do is substitute it into the general formula. So therefore, this is going to be your answer. Now, to find part B, all we need to do is pretty much do the long tedious method. So in this case over here, since I know my T5 value, all I need to do is add it by the common difference, which is -4. If you're adding it by a negative number, essentially it becomes a negative here. That's why I've got a takeaway. So therefore, substitute this into the formula. So what is -11 take away 4? That gives you -15. To find out the 7th term of the sequence, I need to find the 6th term and then subtract it by 4. So -15 take away 4 gives you -19, and therefore if you do the same thing for T8, this is going to give you -23 as an answer. What we're going to be doing in today's lesson is we're going to be finding the value of any term within the sequence using the explicit formula, and this is a lot more time efficient. It's a lot more efficient in terms of the space because you don't need to show as much working out, and I'll show you how it can be used. So number sequences can be represented explicitly, meaning that it can be done very clearly in a very clean way by using the formula down below. By finding the explicit formula for a sequence, it allows the quick and easy calculation of the value of any term in the sequence. So let me just kind of go through what this formula means. So Tn in this case is the value of whatever term you're looking for. So for instance, if you're looking for the 100th term, then whatever the answer is will be that. T1 is just the initial value, the first term in the sequence. We know that D represents the common difference. And what n-1 means is that's one less than the term number. So that might not make sense to you, but for instance, if I was trying to find out, let's say, what is the value of the 100th term. So therefore, I'm trying to find out what is T100 in this case. So it'll be T100 minus T1 plus D bracket. N in this case represents 100. So it'll be 100 minus 1. And if I kind of simplify that down, it'll be T100 equals to T1 plus D bracket 99. So that's what I mean by one less than the term number. I was looking for the value of the 100th term, but if I substitute in, subtract it, simplify it, that's going to be one less than the term number. Okay, so let's look at an example just so you have a better understanding. So this question wants you to find the value of the 30th term in the arithmetic sequence down below. So all we're doing now is just finding out what my T1 value is, finding out what my common difference is, and then substituting it into the formula. So firstly, find out what is your common difference. So in this case, if you notice that it keeps going down, so therefore, because it's going down by the same amount, this is an arithmetic sequence, it's going down by -3. So therefore, common difference is equal to -3. All we need to do now is substitute all the values that I know into this equation over here. I know that T1 in this case, my first value is 21. I know that D is equal to -3, and I know that N in this case represents this number over here, the 30th. So N is equal to 30. Substitute it into the formula, so it'll become T30 is equal to 21 plus bracket -30, -3 bracket, and so forth. What we're going to do now is we're going to simplify this. So therefore, this becomes -3 multiplied by 29. Put this into your calculator. You're going to get -87. And you know how you've got a positive and negative over here. This makes it negative. So therefore, 21 take away 87 is going to give you -66. Now, you might be asking, do I need to show all this working out just to get the answer? You don't need to show every single working out. So for instance, these steps over here are kind of redundant. All you really need to show to me is this step here. Put all of this direct into a calculator, and then you'd get this as an answer. So the second and third step is quite pointless, but I'm just showing full working out though. Alright guys, give yourself 10 minutes so you can actually answer the following questions over here. So answer these questions inside your exercise book, and then just copy the answer on the right hand side on the Ed puzzle page so I can actually monitor this as well. It shouldn't be too hard if you follow the example before, so please pause this video so you can answer these 4 questions. Alright, if you've done this successfully, then this is the answer you should be getting. So for the first question over here, the common difference is going to increase by +7. Put it into the formula, you're going to get an answer of 104. For the next one, it goes up by 14. And your answer in this case is going to be 275 for the 20th term. The third one, the common difference goes down in this case by -8. And therefore, the 30th term is going to be equal to -176. And for the last one, this is going to be a bit more complicated, not really, but because you're doing all in the calculator. But if you do this successfully, then you should get an answer of negative 387 over 20. All right, moving on. Now, so far, we've kind of looked at using this explicit formula to determine the value of any position within the arithmetic sequence. So what is the 100th term value? But what we're going to be looking at now is looking at examples of how to use the same formula to calculate the position of a particular number in a sequence. Okay, so this is the formula that you've been exposed to already, but if you were to rearrange the formula so that you could actually solve for n, this is what the formula would look like. So please make sure you copy down this particular formula into your exercise book. Let's look at an example of how you could actually apply and use the actual formula to get the answer. So in this case, the question reads, an arithmetic sequence has a first value of 120 and a common difference of 16. So D is equal to 16, and you know that your first value is equal to 120. Which term has a value of 712? So in this case, you know whatever this is over here is equal to 712. You're trying to find out what is the value of n. So all you need to do is use this formula and just substitute the values into the formula. You know that Tn is equal to 712. So 712 subtract 120, all divided by 16 plus 1. If you did this correctly inside your calculator, you should get an answer of positive 38. So this means that the 38th number in the sequence will have an answer of 712. That's what the question is saying, essentially. All right, guys, 5 minutes. Give yourself some time to see whether you can actually do the following question. So please pause this video right now and then compare your answers with my answer. If you answer this question successfully, then this is the answer that you should have attained. If you got this correctly, that means you've got a pretty solid understanding of this topic, and now it's time for us to do some review questions. So these are the questions I want you to do. So only 4 questions effectively, but obviously question 2 has many sub questions within it. I don't really expect you to do all the questions of part of question 2. However, obviously, if you think you need extra practice, then do them all. But I think doing just the first column over here is going to be sufficient because it is quite repetitive though. So please answer these questions, and once you've finished answering these questions, these are the answers that you should have obtained. And once you've done this, please actually do the exit ticket for today's lesson. So there's about 10 questions. 8 of them are multiple choice, 2 of them are short answers. This is the end of today's video. Hopefully this video have helped you. I'll see you guys again in the next video. Bye.